Welcome to Easy Math TV. This is the second video in our series on the time value of money. You will find this under that title of playlist. So the playlist actually is time value of money, and there's going to be more videos posted there probably through the end of April, maybe even into May. I should get some more videos in there. But this is the second video that explores simple interest. So the topic is simple interest, and we're looking for the pattern between two of the numbers that are involved in simple interest. We want to answer the question that you see here. Is capital A, which is the accumulated value of an account, is capital A linear over time? And the time variable is t. So we're going to be specifically looking at t and a and whether the relationship between those two quantities is in fact linear. If you missed the first video, we established all the formulas that we needed up here in rows 2 and 3 just to be able to use this sheet as just a simple calculator if we just wanted to calculate the interest or the future value using simple interest formula. And that can be used in a loan situation too. So like if you were borrowing money at simple interest and you wanted to know how much you would have to pay off in total, you could do that using this sheet. So all that you need to do is type in your interest rate and your principal and your time, and then these other two formulas will calculate it for you. But down here, what our purpose today is going to be is we're going to give it multiple values of time. So depending on what amount of time we might have our money in for, what would the future value be? Like, so how much interest would we earn? That's going to go in column D. How much interest would we earn? But then ultimately we want to know what happens to capital A if we change the amounts of time. Okay, so as we change time, what happens to capital A? That's what we're going to be answering today. So just so we're clear, the values of time are numbers that we type in ourselves. So that's why you see this highlighted in gold color. So those numbers, we're just going to start at 2 and we're going to count by 2 and go all the way up to 14. So we're just going to see what happens to our account depending on how long we have that money in for. So, for these different amounts of time. So that is going to change. Our time is changing and our capital A is going to change as a result of that. But these numbers, little r and capital P, are going to be just given. So let's go ahead and establish what the interest rate is. Let's make it, I don't know, 4.5%. And you'll notice that it is formatted as a percentage. You can actually, if you don't go up here and do the formatting for it, you can just type in 4.5% and that will format it for you. And let's say that our initial deposit is going to be $150. And just for the sake of comparison, let's say that see t equals 14 at the bottom there. So let's let t equal 14 and see what we should be getting. Across from t equals 14, we should be getting a capital A of $244.50, and we do have that. So my formulas are correct. So we're going to go across and we're going to talk, we need to put in all these formulas that you see in all these columns that are colored in blue and even the one that's in gray. We need to enter those formulas in now. So our t's are given. So delta t is just as we've done before with other trying to find out what the pattern is between x and y, for example. We had a column for delta x where we took our two consecutive x values and subtracted them. So that's what we're doing here. You'll notice that hang on. You'll notice that I don't have anything in row 5, and that's because there is no t value to subtract from the number 2. So we're starting in row 6, and that's going to equal B6 minus B5. And there is no fixed reference there. So equals B6 minus B5, and then go down to the corner and go ahead and fill down. So you can see that time is going up by 2 years, and that is the pattern that we established. We were counting by 2, so delta t should be 2. Okay, let's figure out what our interest is if t is equal to 2. So if t equals 2, our interest equals $3 times $3 times B5. And make sure that anything that looks like a fixed reference there, make sure it's a fixed reference. Put those dollar signs in for the appropriate values, and then B5 is just B5. Hit enter, and then we can fill that down. So the interest is obviously changing because you're going to have the money in for longer periods of time. So the longer the money is in for, the more interest you're actually earning. That makes sense. But the question is the pattern linear? So capital A, which is in column E now, so in cell E5, you want to type equals $3 plus, so that's our principal, plus our interest, which was in D5. So principal plus interest is equals $3 plus D5, and hit enter. And that's another thing that we can go ahead and fill down. So now we want to calculate our delta A's. And you'll notice that we have nothing typed in row 5 because there's nothing to subtract 163.5 from. So we don't put it in there. We start with row 6. So column F is our delta A's. And in cell F6, type equals E6 minus E5. So you'll notice we're just subtracting consecutive values of capital A. That's just like we would have done before with our Y values. And hit enter, and then fill that down. So I want you to notice not only is delta T constant, but delta A is also constant. And we've talked about what that means. So just for the sake of calculating, let's just figure out what delta A divided by delta T is. That's our slope, by the way, if there is a slope. So in column G, G6, type equals F6 divided by C6, and hit enter. And then fill that down. So that tells us that we do have a constant slope. So there's a couple different things that tell us that indeed capital A is linear. So we can say yes for a lot of different reasons here. The first reason is that change in A is constant when change in time, T, is also constant. So that's a good enough reason right there. But also, change in A divided by change in T is also constant. So that's another reason why it is a linear relationship. Okay? So we've got lots of evidence here to support the fact that with a simple interest situation, the relationship between the future value or the accumulated value of an account, capital A, is in fact linear with regard to time, as it relates to time. Like, subscribe, comment down below with these videos if you find them helpful or you think they might be helpful to a friend who's also taking business math or applied math. Definitely share them with them. Share them with as many people as you can, okay? And I'll see you next time.